Hey guys, thanks for coming back again. If you have subscribed, if you are yet to subscribe, please click on the subscribe button and also on the bell beside it. That will notify you when we drop our new video. Thank you very much. In this content, we want to look at the titration experiment based on the National Examination Council of this year, 2021. So we have a question which says that we are given a solution of 10 gram of NaHSO4, which is sodium hydrogen tetraoxosulfate 6, which is an acidic salt anyway. So we are given 10.6 gram in 1 gm cube, and at the same time we are given a solution B of which the amount in gram that is dissolved in 1 gm cube is unknown. So as we were given x gram of NaOH per dm cube. So the procedure says put A into the burette. A happens to be our acid, which is there in the beaker labeled A. Then we have titrate against 20 or 25 centimeter cube. The 20 or 25 correspond to the volume of pipette used. So the volume of pipette determines the volume of the base. So however, this is what? 25 centimeter cube. So which means that our volume of B used in this video is going to be what? 25 centimeter cube. So we are using 25 centimeter cube of B. Anyway, then we are going to use the methyl orange as an indicator. So this is the methyl orange we are using as our indicator. So, and after this, you titrate until there is a color change. So when there is a color change, you record the volume of acid used, which is VA, of which you can record in this table. At least we're going to perform the titration for 3 times. So this is the table, and this is how you're going to tabulate the initial reading of your burette, which happens to be the first titration, should be 0. So that means that your first titration is going to start with initial of 0. So then after titrating, you would get the new volume after the column would have changed. Then subtract them to get the volume of A used. So with that, we're told to record the value of A used, repeat the procedure for more consistent value, then evaluate the average volume of acid used. So we are also going to evaluate how much volume, if we titrated 3 times and we got 3 values which must be definitely close, and the difference should not be more than plus or minus 0.2. So if that is the case, then we will find the average by adding the 3 and dividing by 3. So that is how to find the average. Then evaluate the average volume of acid used, which I've explained. Then from your results, determine the concentration of B in mole per dm cube. Anyway, from the first experiment and the result of the experiment, we will be able to calculate or deduce whatever is in this question for us to find. So let's see how the experiment will be carried out. Now let's see how the experiment goes. This is our pipette. This is in place of our white tile, which is a spring. So then we have the burette hang on the rotor stand. We have B, which is the sodium hydroxide. We also have our A, which is sodium hydrogen tetrasulfate 6 rather, and our methyl orange indicator. Now, when performing this experiment, we need to observe all due precautions as pertaining to titration, and one of which are you have to rinse the burette with an acid, also rinse the pipette with the base, while the conical flask, which is meant to be for the mixture, will be rinsed with water. And at the same time, other precautions will be discussed as we carry out the experiment. So now let's move on. The first step is to add acid into the burette, and this is acid. So we're going to add it into the burette straight away. So now we ensure that we concentrate on the lower meniscus so that we can have an exact recordings of 0. So I think the burette has been filled with an acid. I can actually adjust it down to see if I've made my correct measurement, and that is correct. So now what next? We fill the acid into the burette, then let's pipette 25 centimeter cube of the base into the conical flask. So this is the base. We are going to suck the pipette. So this has gone beyond what we're expecting, so we need to adjust. We need to adjust it back to the marked point. So, and And that's it, exactly. So we go. So with this, we can start the titration, but firstly we need to introduce our indicator, which 2 or 3 drops is okay to make it visible. I think this is color yellow, so we can add one more drop to ensure that that is visible enough. This is the color, which is yellow. Now we begin the titration. Okay, now we have the color change. We have the color change now from yellow to pink, so the readings of the burette will be taken from here. So we're going to take the reading from the burette. So the volume of AUs will be recorded in the table, and the volume of AUs according to the burette reading here is 10.8. So we have 10.8 to be the volume, so that will be at the final 10.80. However, all burette readings should be taken in 2 decimal places. All burette reading should be taken in 2 decimal places. So we have 10.8 as recorded in the table. We have 10.8 as recorded in the table now. So what next? Let's go for the second titration. Before then, we have to subtract the initial from the final. We have to subtract the initial from the final, so that will definitely give us 10.80 minus 0.00, so that gives us 10.80. Now I don't need to refill my burette back to 0 just because we have 50 centimeter cube and we can get 2 more of these without refilling the burette at all, so I don't need to refill back to 0. I will have to start my initial with 10.80 also. So now let's go for the second titration. So we dispose this and have to pipette another 25 centimeter cube of the base. So we need to adjust this to the marked point. So sorry. Fantastic. This can be annoying sometimes. Oh, exactly. So we take it up from there to determine the second volume of A used. So let that be. Our indicator will be added once again. So 1, 2, 3 drops. So I think we have a yellow color again. So what next? Let's go for the titration. So good. Here we have the burette reading to be. Burette reading is 21.7, so we record that into 21.7. So we have here 21.70. After subtracting, we got 10.90, so which is just 0.1 difference to this, and that is still acceptable. So from there, we take our initial with 21.70. So that will be our initial for the third and the last titration. So for the third titration, I make my measurement again. I measure the base. So that's it exactly. So let's move on. So with this, let's take the third titration rather. So good. So for this third titration, we have 32.3. We have 32.3. Let's record that into the table. We have 32.30. So subtracting it from here, we would get 10.70. So 10.70 will be the next value. So we can go ahead with the numerical work that is left in order to find solution to the question. So now we can determine our VA, which is the average volume of A used, and that would be equals to 10.80 plus 10.90 plus 10.70 all divided by 3. So, and that VA will definitely give us, that is 10.80 centimeter cube. The unit is very important in chemistry because the omission of that unit might lead to deduction of mark or no mark awarded at all. So let's be mindful of the unit we give for different parameters. So now let's go ahead to determine whatever we are meant to determine. So we have determined the volume of A. So question 1 says concentration of B in mole per dm cube. So that is CB. We are actually looking for CB where we have our CA. Anyway, the CA can be determined because look at question 2. To find our CA, we have automatically solved question 2 because it says concentration of A in mole per dm cube. Don't forget that A is NaHSO4. So which implies that the molar mass of A is going to be equals to, that is, we're going to have 23 plus 1 plus 32 plus 64, which is gotten from the 4 times 16, the relative atomic mass of oxygen. So we have 23 plus 1 plus 32 plus 64. So that gives us 120 gram per mole, 120 gram per mole. That is the molar mass. So to find the concentration, we would say the mass concentration of the molar mass. So Ca will be equals to, mass concentration is 10.6 over 120. So that gives us, let's put that Ca equals 0.088 mole per dm cube. So that happens to be the concentration of the acid. So now, after taking up this, we can go ahead to find the concentration of the base. So with this, we have provided a solution for question II. So now for question I, how do we find the value of the value of concentration of B? So that is somewhat easy using the formula Ca VA all over CB VB equals NA over NB. So that's approximately, when we calculate, we're going to have Ca to be 0.088 times VA, which is the average volume of acid used, and that is 10.80. So thereafter we have the CB, which is what we are looking for, CB times 25, which is the volume of pipette all equals. If we write the equation of the reaction just like we have written here, the number of mole of acid to base is 1, 2, 1. So we take it that way. We take it that way to have 1 all over 1. Above your table, you need to record the type of indicator used and the volume of pipette used. Is very important. So now the next thing is, let's calculate. We have 0.088 times 10.8. Okay, that gives 0.950. So let's take it down here. I have 0.950 over 25 CB or equals 1 all over 1. So what next? Let's just cross multiply so that CB will be equal to 0.950 over 25. So 0.38 rather. So CB, the concentration of the base, is 0.038 mole per dm cube. So that is the concentration of the base. So with that, we have proper solution to question I, which is the first question, question I, proper solution to that. So that's question I. Let's proceed to find the value of x. The value of x happens to be the mass concentration of B, because we are told that B is a solution containing S gram of NaOH. So which means that for looking for x means we are looking for the mass concentration of x. So to find the mass concentration of x is somewhat easy. So how do we do that? We still use the same formula that says that molarity, which is not concentration, equals mass concentration over molar mass. And don't forget that the mass concentration is x. So, and the molarity of which we calculated now is 0.038. So we have 0.038 will be equal to x over the molar mass of NaOH is 40, which is gotten from the relative atomic mass of sodium plus oxygen plus hydrogen. So after this, so which means x is going to be equal to 40 times 0.038. X equals 1.52 gram per dm cube, or anyway, gram. So 1.52 gram is enough because we're not told that. Anyway, we have to put it because dm cube 1.52 gram per dm cube. So good. So far so good. We have gotten the value of x. So now the last question says, what mass of Na2SO4 is formed during the reaction? So that is fantastic. So if, according to the equation, 1 mole of NaOH produces 1 mole of Na2SO4. So we have 1 mole of NaOH produces 1 mole of Na2SO4. So how many mole is this 1.52 gram of sodium hydroxide? And don't forget that number of moles is equal to concentration times volume. And the concentration of B is 0.038. So which means that N will be what? 0.038 times the volume of pipette used. So which means that we have 0.95 moles of NaOH. So in that case, since 1 mole of NaOH produces 1 mole of Na2SO4, therefore we are going to have 1 mole of Na2SO4 produced as well. In that case, so if 1 mole of NaOH produces 1 mole of Na2SO4, and the number of moles of NaOH is going to be concentration of NaOH times the volume, which is 0.038 times 25. So and that eventually gives us 0.95. So since 1 mole of Na2SO4 is produced from 1 mole of NaOH, then what would happen? definitely they will equal moles produced. There is 0.95 moles of Na2SO4 is produced, since they have equal moles according to the equation. So if 0.95 of this is used, then 0.95 moles of this will also be produced. But what will be the mass of that 0.95? So then we use the mass is equals to number of moles times molar mass. So in that case, what will be the molar mass of Na2SO4? So molar mass of Na2SO4 will be 2 times 23 plus 32 plus 64. 139, so we have 139 gram per mole. So definitely the mass that would be produced is going to be equals to the number of moles, which is 0.95 times 139. 132.05 is the mass of Na2SO4 produced. Thanks for watching, guys. Please subscribe to our YouTube channel. It's free. Thank you.